Hi everyone, welcome back. So today we are going to actually do some review as we prepare to approach our standards 6.ee.a.1, write and evaluate numerical expressions involving whole number exponents, and standard 6.ee.a.2, write, read, and evaluate expressions in which letters stand for numbers. So the review of exponents. Exponents show repeated multiplication. Exponents represent how many times a number, the base, is multiplied by itself. So if you take a look at this example here, 5 to the third, this is our exponential form. And if you look at 5 times 5 times 5, this is where I'm taking the base of 5 and multiplying it by itself the number of times as outlined by the exponents. This is our expanded form. And if I multiply that together, I get 125, which is our standard form. Okay, and this is our exponent or exponential form. Exponents are sometimes considered power. So those words are synonymous. So the 3 is an exponent, which is also can be considered as a power. So we would read this as 5 to the third power or 5 cubed. Let's take a look at a few examples. So here, in order to evaluate these examples, I first need to evaluate them independently and then to add or subtract as outlined. So 3 to the fourth power is 3 times 3 times 3 times 3, which is equal to 81. And that is going to be added to 9 times 9, which is also 81. So we have 81 plus 81 for a final answer of 162. For the next example, -5 plus 5 to the third power, we're going to rewrite that -5 and then we're going to expand 7 to the third power, which is 7 times 7 times 7. And when I multiply that, I get 343. Here I'm working with integers. I have different signs. I have a -5 and a positive 343. So I'm going to subtract and keep the sign of the larger number. So here this would be a positive 338 because the larger number 343 is positive. All right, next example. So in our previous lesson, we talked about anything to the 0 power. Any number value raised to the 0 power is 1. So 10 to the 0 power is 1, plus 23 to the 0 power, which is also 1, plus 1/2 to the 0 power is 1. So 1 plus 1 plus 1 is equal to 3. Our next example, so in the parentheses, we have 5 squared, so that's 5 times 5. And that's being multiplied by a negative value on the outside. And then I have 3 to the 6th power, which is 3 times itself 6 times. Not to be confused with 3 times 6. 5 times itself is 25. And I bring down my negative sign. I'm going to bring down my minus here. 3 to the 6th power is 729. Here I'm working with my integers, so I have same signs. I'm going to add those and keep the sign. So that gives me a final answer of -754. Number 5, Carlos said the expression x plus x plus x and x to the third are equivalent. Is he correct? So we know that when we are working with exponents, we're multiplying the base by itself the number of times expressed in the exponent. So x times x times x would be the expanded form of x to the third. Therefore, Carlos is incorrect, because x plus x plus x cannot be equal to x times x times x. One is addition, the other is multiplication. Now let's take a look at the distributive property. The process of distributing is to multiply a number or variable by a group of terms added together is the same as doing each multiplication separately. So here is an outlined, if I take the value a and I multiply it through to the parentheses, I'm going to get a times b, or ab, and a times c, which is ac, and then I can add those two together. Let's go ahead and take a look at these examples. So for number 1, I have the number 2 on the outside, and I'm going to distribute that through to each value in the parentheses. I like to draw my arrows because it reminds me that I need to multiply the 2 not only to the 3, but also to the 9x. 2 times 3 is 6. 2 times 9x is 18x. These are unlike terms, so I leave it there. I'm going to do the same thing here. Okay. So now I have 5y times y plus 5y times 3. Now here I have y being multiplied by itself. So y times y is going to be y squared. And there's an invisible 1 here. So 5 times 1 is just 5. So 5y times y is 5y squared. 5y times 3, 3 times 5 is 15, and I bring down the y. I cannot combine these because, again, these are unlike terms. They have the same variable, but their exponents are different. We'll talk about this a little bit more in our next lesson. Let's go ahead and distribute the 6 through to each value. So this is a negative 1, so a positive times a negative remains negative. 6 times negative 1 is negative 6. And then 6 times negative 4b is a negative 24b. Okay. Thank you for watching and have a great day.